Hello everyone, welcome to the Share Your Green Design podcast. Before we begin today's episode, just a reminder that you can follow and subscribe to us over on Spotify, Apple, or wherever you get your podcasts, and you can also find the full video version of each episode over on YouTube. We're also on Instagram, LinkedIn, Twitter, and WeChat at Share Your Green Design. That's all one word, Share Your Green Design. And remember, the podcast is only one small part of what is an ever-growing platform. So head on over to shareyourgreendesign.com to keep up to date with the latest in sustainable architecture, engineering, and construction. We've got projects, news, research, events, competitions, student work, jobs, everything you need. We'd love to have you as a visitor, but also as a contributor, so you're always welcome to send us your own projects, ideas, events, job openings, and much more. You'll find all the details on shareyourgreendesign.com. Once again, that's shareyourgreendesign.com. Thank you again for your support, and with that, we hope you enjoyed today's episode. Okay, so anyway, David, thanks for doing this. Only a couple of months after the last time we spoke for ArtConnect, but I think it'll be interesting to dig more into specifically into sustainability in the idea. So, do you want to introduce yourself to our audience, who you are, where you're from, what your background is, and also kind of introduce the idea behind the book that you've published recently?
Sure. My name is David Wallance, and I practice in Brooklyn, New York. I practice architecture. My firm, DRA, Design Research Architecture Wallance, is a small practice, but I've had a long, large firm background. I was with Edward Larrabee Barnes for 8 years, with the Polshek Partnership for 12 years, and FX Collaborative for 5 years, all large international award-winning firms. At the time that I was working with Polshek in 2005, I was introduced to a couple of entrepreneurs who wanted to develop a scalable system of modular construction based on intermodal transportation. Initially, we thought we were going to recycle shipping containers, but we quickly realized as we got into the technical nitty-gritty that really wasn't a scalable approach. So we completely reinvented a module based on shipping container dimensions. And we were on our way to building our first building. We had taken out nearly 40 patents, and the global financial crisis put a stop to the enterprise. So I found it very hard to let the idea go. We had done some very exciting work. And so in 2009, I began writing a book. And it took 10 years to more than 10 years to get it into publication. I wasn't working on it that entire time, but the ideas developed over time, and I began to see that modular architecture, equitable urbanism, sustainable development, and globalization are all very interconnected threads. And so I broadened the theme of the book to include more than just the technical matter of what I call intermodal modular architecture. And I framed the subject matter in a context that included cultural ramifications, sustainable development, innovation and resistance to innovation, urbanism, and so on.
It's interesting that, particularly that last point about trying to weave in so many factors that go beyond the kind of traditional realms that the architect might occupy themselves within a brief. So you mentioned culture, economics, even broadening out to manufacturing itself. And when we, in the context of sustainability and climate change, some of the most convincing arguments and some of the most convincing approaches I hear to tackling climate change, they don't focus on trying to, say, retrofit or adapt or add to a certain structure, or they don't have that narrow of a focus. They tend to stand back and they tend to ask kind of deeper questions about how we live and how we function as society, how we operate, how we sustain ourselves as a society. And what interested me about your idea and the book is you can see elements of that in your idea. You're not zoning in on a particular material or a particular site. You're standing back and you're asking fundamental questions about how we build in cities, and particularly for you, how we use land. Could you talk maybe a little bit about land use with your project? Because one of the critical things you talk about is how this is almost unanimously accepted, that one of the most effective things we could do to combat climate change is to transition more and to continue transitioning to urban environments, to denser environments. So, can you talk a bit about how your idea and your system facilitates that move and that migration to cities?
Right. Well, in the United States, we turned towards a development model in the late 1940s based on Levittown. William Levitt discovered that he could build inexpensive, large-scale suburban tract development on undeveloped greenfields and turn a nice profit, and also provide housing for what at the time was a real housing crisis at the end of World War II. That became entrenched as the American development model. And what I discovered in my research was that, yes, it's very important to design energy efficient buildings, net zero buildings if we can. But that doesn't generate the kinds of reductions in greenhouse gas emissions that simply doing less driving does. And paradoxically, if you think about net zero on the building scale, on the single family house scale, what you have is a 1 or 2 story house with a roof covered with solar panels. And if you want to propagate that model, you need Levittown style suburban subdivisions. You can't do that in a dense multi-story urban context. So much of our focus on the highly sustainable, highly energy efficient single family house is actually misplaced. We need to be finding a way to bring people back to cities, especially middle class people who are the ones with the means to leave the city and move to the suburbs. The problem is that urban housing, multi-story urban housing, especially high-rise urban housing, is far more expensive to construct than the suburban subdivision on a piece of empty land. So what happens to young families when they start raising children is they find that it's impossible to live in a cramped urban apartment. And so they start looking for more space, and they basically, what happens is you drive until you qualify. You drive as far away from the urban core as you can get until you find housing that's within your budget. And this produces automobile dependent urban land use, or regional land use, I should say. So what that means is we need a scalable solution of industrialized mid and high-rise housing that can use advanced manufacturing, all of the things that we've learned how to do with automobiles and consumer electronics and so on, to bring the cost of high-rise urban housing down to where it's competitive with the single-family house in the suburbs. And to do that, we need large enough markets, we need global markets to sell that industrial product, our industrialized housing solution. We need to be able to sell that worldwide. We can't sell it the way modular housing is sold today, because the modules that most manufacturers build are oversized and expensive to roll down the highway. And so modular manufacturers are limited to these 150 to 200 mile market radiuses, and they're extremely vulnerable to economic cycles. They can't really invest in research and development. They can't really bring costs down. So when you think about it as a global solution, what we arrived at in our thinking was a module should be the size and shape of a shipping container, because that is the largest sized volumetric unit that you can move around the world inexpensively. And from there, then you start to go into the technical problems that have to be solved to make that kind of solution work.
Mm-hmm. That point about bringing costs down is probably, and we see it not even just in architecture, we see it almost across every faction of how we live, that the way we often damage the climate is by trying to make things cheaper and cheaper. This is ironically one of those instances where making something cheaper, i.e. housing or the production, I guess when I say making cheaper, it's probably fair to say make it more efficient. And it's the efficiency that brings the cost savings. But you can't underscore enough how important it is to encourage people away from a suburban way of life, which some people move to rural or suburban areas because they have particular needs that suit them to. But as you point out, a lot of people live in suburban areas simply because they can't afford to live in urban areas, and those people probably would prefer to live in urban areas. And there was a study last month that came from the University of Colorado. I'll put it up on screen actually, so you know. But I'm pretty sure it's the University of Colorado, and they ran an algorithm of 5,000 urban and suburban living patterns, and they found across the board that no matter what the density of an urban environment, whether it was a tall high-rise urban environment or a mid-rise urban environment like say Paris or European cities like Madrid, across the board it was always more effective from a sustainability point of view to maintain an urban environment rather than a suburban environment. So as you say, that question about understanding and figuring out a financial model that can allow people to move back into cities is probably the single most underlying important thing we could do to combat climate change. Because then we can start to figure out, okay, if we can get the land use sorted, then we can figure out what materials do we use to build, what infrastructure do we underlay, how do we power that infrastructure. But if you can sort out the human habit first of moving and the human need to move away from cities, it's kind of a good base to start from.
Absolutely. The problem is not just in Europe and the United States. In fact, 90% of the urban growth in the world is happening in Asia, South America, and
Africa.
Africa. Thank you. Yeah. So this is a problem that has to be addressed before those nations adopt Western-style sprawl patterns, and this is a ticking time bomb as more and more people enter the middle class globally, have the wherewithal to purchase a car, and then use that car to get away from expensive urban housing.
Mm-hmm. On the because you talked about the transportation of these units and matching them with shipping containers, this kind of modular unit. One of the, and I can imagine two of the pushbacks that people would have against the idea would be, number one, that there would be emissions, that the emissions generated by transporting this unit long distance, say Asia to Europe or Asia to America, would do more to damage climate or damage the environment than if you sourced it locally. And then the other, and this is, I think I was saying to you before, this is something that occurred to me when I first read the book, about the peculiarity of shipping these, because from I understand, you propose shipping these almost ready built, not flatback, but actually constructed upright in the kind of modular form, so they wouldn't be kind of shipped flatback and assembled on site. That people would point out that, say, you could ship more of these if they were flat packed, or that it would somehow be more efficient to ship these flat packed. But you do lay out responses to these in the book. But do you want to map out what the response is to that, and what the rationale is for those two approaches?
Right. Well, to begin with, ocean shipping on container ships is 10 times more energy efficient than shipping by truck on a highway. So immediately there's an efficiency in transportation just by going across water. If you look at it that way, the trip from, let's say, East Asia to New York, which is about 12,000 miles, comes down to about 1,200 miles in equivalent highway transportation. But one of the lucky benefits of the system that we developed with our structural engineer is it's an all steel system. There's no concrete, no structural concrete in the modular system we're proposing. So it's about 1/3 the weight of a conventional building. So if you're transporting materials that are 1/3 the weight of conventional building materials to a job site, you can say that 1,200 miles equivalent highway transportation now becomes 400 miles of equivalent highway transportation to ship halfway around the world. There's a certain bias among people who are interested in sustainable design that you must procure buildings locally, and I simply don't agree with that. I think you have to look at it from a much more rational point of view, and ideally based on life cycle assessment. It might be true for strawberries, that you don't want to ship strawberries from Australia to New York, but it's not true of complex structures like buildings, and especially if you can master the LCA analysis of how they work. So moving from there to the next part of your question, which was, what about shipping air? How can that be energy efficient? Well, again, it's true. If you're shipping a bed from IKEA, it makes no sense to ship that bed fully assembled. It makes sense to ship it flat packed, because a bed is a single system that doesn't involve the interrelationships of highly integrated technical systems, HVAC, electrical, plumbing, and so on. When you think about architecture, what you're really talking about is a complex, interwoven set of systems that comprise what I like to call embodied intelligence. A friend of mine who is a physicist told me that this, in some ways, resembles the laws of thermodynamics. That the idea of embodied intelligence is kind of like an idea about embodied energy. If you can knit together all of those systems in a factory efficiently, what you're shipping isn't really air. What you're shipping is space that has a very high level of value added to it in the sense of its surrounding systems that are creating an interior environment that you can live in. Flat pack, when you ship a flat pack structural system to a job site, you're really only shipping about 15% of that building's constructed value. When you ship a volumetric unit of construction, you're shipping about 80% of that building's eventual constructed value. That 80% manufactured off-site is far more efficient than putting up a flat pack structural system and then very conventionally going about the process of adding HVAC, adding plumbing, adding electrical, adding partitions, adding finishes, adding fixtures and appliances, and so on. Mm-hmm. So that's the argument. That it's the argument about embodied intelligence.
Yeah, it is that phrase, embodied intelligence, that actually it perfectly encapsulated, because it's like rather than thinking about the empty air inside this unit as being somehow leftover, it's actually integral to the volume, because the proportions that the proportions through which the unit is assembled is so fundamental to the way it operates. It's the exact same as the way it operates. So therefore, as you say, even the air inside and the proportions and the joinery is all carries an embodied intelligence, and also just an embodied effort to put together, which is much easier carried out in a controlled factory than on an unpredictable, say, construction site. I think probably as well, we have the technology. We're going to talk about. You mentioned already LCAs. That we have the technology now to actually answer these questions, because it sounds logical that you should efficiency is all about saving space, shipping as much as possible. But today, and particularly in building science, we have the technology now to actually understand the different methodologies. A bit like I mentioned that study from last month about density in cities. That was all figured out through algorithms. We do now, and architects have sometimes even free technology that can actually help us answer some of these questions. And I guess for your kind of system as well, the technological age that we lived in gave certain reinforcement to the idea. We talked last time about even about the kind of connection to the iPhone, and how this kind of system almost seems more feasible and more logical now in the age of kind of highly tuned and yet somehow adaptable technology.
Yeah, I mean, I know it's not central to the topic of this interview, but I think it's worth pointing out that the approach that we take is to create the equivalent in architectural terms and modular architecture of an operating system that is the backbone of a smartphone. And that lends itself to the development of myriad third-party apps. Architects around the world can contribute to this open source system by developing all the subordinate components that would go into a housing module. Highly idiosyncratic kitchens and bathrooms and solar shading systems for facades or balconies or winter gardens. The possibilities are virtually endless. And architects now have a global market to sell into. So if you're an architect practicing in Brooklyn and you can raise a little bit of money to develop your concept for, let's say, a wood-lined bathroom, and it's all plug and play. In other words, it fits into the preset dimensions of the module. You have a global market to sell that to. And it has the potential to open up new pathways for architectural practice to generate revenue, to supplement conventional design practice.
I mean, you say it's off topic, but I can see how that operating system, the flexibility that would allow. I can definitely see not just architects, but material scientists, even ecologists, etc., using that OS to further advance the cause of sustainability of how people live, trying to find systems which plug into this OS that can say that can save energy through basically operational energy use, and even generating energy, disposing of waste more effectively. And as we kind of talked about last time, when you establish parameters, you actually it's like the discipline of the parameters gives freedom for whatever cause you're interested in, whether that's lifestyle or climate or sustainability or equality, etc. It's all, as you say, it is fundamentally all linked, and any solution to climate does have to tap into culture. It has to tap into how we live.
It also has to. I mean, I want to sort of circle back a little bit on the word cheap. What is possible is not only a reduction in cost, but actually a significant increase in quality and an increase in design choice. I don't know about other parts of the world, but where I practice in New York, market rate housing has basically become a formula. The floor plans are pretty much standardized. The finishes and details are pretty much standardized. There's not that much invention going on. It's codified at this point. With an OS and a global community working together collaboratively on the system, I think a great deal more invention and creativity is going to be brought to bear. And we shouldn't be talking either about minimal-sized dwellings. We have this idea of the micro unit in New York that is going to solve our housing problems. These 300 square foot units that, a young person right out of college would be willing to live in.
No, I wouldn't.
You wouldn't. But this is not a solution for families.
Definitely.
Nor is it a solution for what we really need, which is intergenerational housing in environments. So we have to get away from the stigma that's attached to modular and really think of it as quality for less money, more space, all of these things in one package.
Can we talk a bit about the construction stage on site of the module and of the system? Because you make some good points in the book about how the construction process of your system looks different to the construction process of a traditional structure, and there are a lot of elements to that which do lead to reduced emissions on site. It's a faster construction. There's probably effectively no or very little waste, I imagine, apart from any residue waste from during transportation, and probably a lot less because it's faster. And you mentioned cost, that time is money. Probably significantly faster to build with less disruption, less traffic, less pollution. What are some of the advantages you see during the construction phase of this versus traditional construction?
Well, I think you just actually summed them up very
Yeah,
nicely.
there you go.
We did a study for high-rise student housing in Greenwich Village in 2014 that showed the construction manager's analysis of truck traffic showed that at least 50% fewer truck trips to the job site would be required, and conceivably as much as 80% fewer, because everything is coming in the modular package. And these are not oversized modules that require very careful transportation route planning and street closures and that kind of thing. These are modules that are trucked, the size of which are trucked through city streets every day. So the smaller module facilitates transportation, staging, crane pick, and the truck moving off and going back to pick up another module and bring it around again. So neighborhood disruption is greatly reduced. This was a roughly 350,000 square foot student housing facility, about 12 stories high, variety of different towers, but they averaged about 12 stories. We did a schedule analysis that showed they would be finished on the outside, looking like a finished building within 4 months of completion of foundations. They go up that quickly. And then from there on, the work that's going on inside is basically invisible to the neighborhood. To the neighborhood, it looks like a finished building. There's mateline patching and mechanical and electrical and plumbing hookups. That goes fairly quickly as well. That's done in 5 to 6 months, and you have a completed building ready for occupancy. So from the point of view of dense urban neighborhoods, this is a far less impactful method of construction.
Mm-hmm.
In terms of traffic, in terms of tailpipe emissions, in terms of disruption to pedestrian movement, all of that.
Mm-hmm. And on the other end of the scale as well, moving all the way to disassembly, because you make you focus on this, and I think is it chapter 7 that focuses on in your book that focuses on sustainability. You talk about cradle to cradle and the cradle to cradle cycle, which obviously a lot of people will be familiar with the cradle to grave cycle, but we're increasingly becoming conscious of the importance of what happens beyond waste. So the idea of disassembly and reuse, and you put forth the case of how your system feeds in or complements this idea of cradle to cradle and design for disassembly. So do you want to spell out the advantages at that end of the spectrum of when the building life cycle is? I'm trying not to give it the answer this time. But when the building life cycle is completed, what are some of the benefits versus a traditional system?
Well, first of all, Neil, it's very gratifying that you've read the book so closely and have the answers. It's nice. It's nice feedback. But so, design for disassembly is a very difficult aspirational goal. It's possible to design for materials to be reused, but for actual building systems to be reused in their assembled state is extremely difficult. I'm not even sure it's achievable. Mm-hmm. But what is a wonderful byproduct of standardization of a building module on the dimensions of intermodal transportation is that you can take those buildings apart at some future date, that there's no welded connection, everything is bolted. You can unbolt, take them down. If a little refurbishing is necessary, that's fine. But then you can put those modules back together in a configuration that is the same as the original building, or it's like a box of Lego parts. You can rearrange them in a different configuration on a different site. So the intermodal modular system is inherently designed for demounting and inherently designed for reconstruction. Nothing really, certainly not the structural systems or facade systems. None of the major systems need to end up in landfill. Mm-hmm.
This is I guess to conclude, it's kind of an open-ended question, but what do you, and it's open to interpretation, but what do you think has to happen in order for this system to be adopted en masse? Because last time we talked about changes which can happen in architectural education, about teaching more about industrial design and trying to understand architecture as product, not just as artifact. But what do you think has to happen to the larger industry? Do we just need to be braver? Do we need to reach out more to people who manufacture materials to get them more on board? Do architects need to start engaging more with trying to grow these kind of systems and almost stepping into the role of manufacturer? What do you think could happen in the future for this to be widely adopted?
Well, I think there's a desperate need for investment capital, and big capital, real investments, like the kinds of investments that have gone into social media companies, into Amazon, into Tesla. We should be treating housing as an entirely new high-tech industry, with the kind of commitment to research and development, to marketing, to cross-disciplinary changes that are desperately needed. We have to get out of the siloed way we think about design and think about it the way automotive manufacturers think about putting a car together. So I think capital will then draw architects to participate, especially if we can really open it up with an operating system, with an open source collaborative approach. I think the idea of architects around the world really working together on a common language is a tremendously powerful idea.
And it's exciting, even from someone like myself, kind of the beginning of my career. The idea that these kind of possibilities are there is in itself inspiring. To kind of wrap it up, and even before we came on here, we were talking about climate and weather, and how we're even seeing the effects of climate change becoming more apparent. When you think about climate change, and I guess when you think about the contributions of buildings and the built environment to climate change, are you optimistic or pessimistic about the future, about what we can do? You're smiling, so I hope you're optimistic. Or is it a laugh of resignation? But yeah, are you optimistic or pessimistic that we actually have the drive, the energy, the tools to make a meaningful reversal on climate change?
Well, I think architects are way out ahead of the politics of climate change. Architects are at the forefront, and we have a lot of intellectual capital that's been built up in finding solutions to energy performance of buildings. Building codes have really made huge strides in the last 10 years. But I thought about your question over the weekend, and I really, the framework of optimistic versus pessimistic, it doesn't work for me. I don't think it's possible to be optimistic. I think we're in a dire situation. Somebody said, I read recently that optimism is the belief that things will turn out all right. Everything's going to be fine. I don't subscribe to that, but I am hopeful, and hope makes no assumption that things are going to turn out fine. It simply is the belief that through individual and group agency, we can make things better in some way. So I'm not optimistic, but I'm hopeful.
That's a good way to end it, I think. So just one more time, what's the name of your book?
It's The Future of Modular Architecture.
Cool. I'm sure if you Google the future of modular architecture, David Wallance, I'm pretty sure you'll find it. And there it is. Who did I've always been meaning to ask you, who did that front cover? Who did the graphic for that? It's actually it's really beautiful.
Well, I did the graphic myself, actually. It's from a competition proposal for a modular solution that I entered in 2017.
Awesome.
Yeah, it's actually the drawing that the cover is based on is an illustration in the book.
I've seen it. I know I've seen it somewhere. The project is in the book, isn't it? It kind of details the project uses as an example. Anyway, that's a side note. Yeah, David, thank you for doing this, and it was a extremely fulfilling hour that I told you would be a half hour. So sorry, but thanks for doing this.
You're welcome.
That's all from us for now, so thank you for tuning into this episode of the Share Your Green Design podcast. Just a reminder before you go, you can subscribe to us over on Spotify, Apple, or anywhere you get your podcasts, or if you prefer watching the conversation, you can find us on YouTube. You can follow us over on Instagram, LinkedIn, Twitter, and WeChat at Share Your Green Design. That's all one word, Share Your Green Design. And remember, the podcast is only one small part of a much larger platform dedicated to sustainable architecture, engineering, and construction. To keep up to date with the latest projects, news, research, events, competitions, student work and job adverts, head on over to shareyourgreendesign.com. Thank you everyone for your support, and we'll see you next time.